Hello students, welcome to our next class on inverse trigonometric functions. So in this video we are going to see our next concept, that is composition of inverse trigonometric functions. So students, we have already seen the composition of two functions in chapter 1. A light recall of that. If f composition g of x is identity function, then f and g are inverses of each other. We have learnt this. The converse is also true. That is, if f and g are inverses of each other, then f composition g will be x. Here we have to note that f composition g is a function from g to f and g composition f is a function from f to g. Always we will misguided that f composition g will be from f to g and g composition f will be from g to f, but it is not so. It goes in reverse. F composition g is from g to f and g composition f is from f to g. So for the above statement to be valid, that is what? F composition g of x is equal to x implies f and g are inverses of each other. For this statement to be valid, x must be within the domain of g and range of f. Clear, children? F and g of x is equal to x implies f and g are inverses of each other only if x is in the domain of g or in the range of f. Clear? Same way, g composition f of x is equal to x, then g and f are inverses of each other if and only if x is in the domain of f and range of g. So this statement will be little bit confusing. It will be clear to you if we look at an example. This example, actually you will be doing this in your classes 8, 9 like that without knowing that this is composition function and without knowing that they are inverses of each other. Supposing that if one function is a square function and the other function is a root function, then the composition will give you x. Is that clear? Because root of x the whole square. Then you would have been taught that root and square will get cancelled and the answer will be x. Right? Or x square, the root of x square, the answer is x because the root and square will get cancelled and it will be x. But why it is? Because it is they are root and the square functions are inverses of each other, and so their composition will give you the answer x. Is that clear? So the same concept we are going to use in our trigonometry and inverse trigonometry functions. Okay? Okay. So sine inverse of sine x is equal to what? Sine inverse is inverse trigonometry and sine is trigonometry. They are inverses of each other, so the answer will be x. But remember the condition, that is the x must be in the domain of the second function, that is sine function, and it must be in the range of sine inverse function, that is the first function. So recall what is the domain of sine. In order that the inverse to exist, so the domain of sine is minus pi by 2 comma pi by 2 and the range of sine inverse is minus pi by 2 comma pi by 2. And sine inverse and sine will get cancelled, right? So look at the next one. Sine of sine inverse x is equal to x only if x is in the domain of sine inverse and the range of sine. So what is the domain of sine inverse? Minus 1 comma 1. What is the range of sine? Minus 1 comma 1. Clear? If that is the case, then sine and sine inverse will cancel each other and you will get the answer as x. That is, cancel each other in the sense, what does it mean? The composition of sine and sine inverse will give you the identity function. Clear? So, if we have to cancel a function and its inverse function, then we have to be very careful to see whether x is in the principal value or not. Okay, you have to check whether x is in the principal value. So for that you have to know the principal values of all the trigonometric functions. Clear? So these are the principal values of all the trigonometric functions. Okay, please make a note and by heart it. You have to be very clear with it, and these formula must be in your fingertips to answer these questions. Okay, now let us see some problems. So first problem, sine inverse sine pi by 3. So what is our first priority? We have to check whether pi by 3 lies in the principal value or not. So what is the principal value of sine? Minus pi by 2 comma pi by 2. Correct? Minus pi by 2 comma pi by 2. So pi by 3 lies in the interval minus pi by 2 comma pi by 2. Therefore directly we can cancel sine inverse and sine, and we can write the answer as pi by 3. Now take the next example. Sine inverse sine 2 pi by 3. Now see, 2 pi by 3 is 120 degree. It does not lie in the interval minus pi by 2 comma pi by 2. So we cannot write the answer as 2 pi by 3. So what we have to do? We have to make 2 pi by 3. We have to change 2 pi by 3 so that it lies in the interval minus pi by 2 comma pi by 2. So how to make it? 2 pi by 3 lies in the second quadrant. So any second quadrant value, to make it first quadrant value, we will do pi minus theta. So it will be pi minus pi by 3 will give you 2 pi by 3. Clear, children? So 2 pi by 3 can be written as pi minus pi by 3. So sine pi minus theta is nothing but sine theta. So sine pi minus pi by 3 is sine pi by 3. Now sine inverse and sine will get cancelled, and we can write the answer as pi by 3, because pi by 3 lies in the principal value branch, that is minus pi by 2 comma pi by 2. Now let us take the next example. Cos inverse cos 2 pi by 3. Cos inverse cos 2 pi by 3, we can directly write the answer as 2 pi by 3. Why? Because the principal value of cos inverse is 0 comma pi, and 2 pi by 3 lies in the interval 0 comma pi. So 2 pi by 3 is in the principal value, therefore we can directly write it as 2 pi by 3. Clear? So now you are in a position to solve the problems yourself. So take these problems as assignment and try these problems for yourself. Okay. Thank you, children. Bye.